Hello, in this video we're going to go through learning target 124, which is about graphing linear inequalities. So those statements with greater than or less than symbols. So the first thing I want to do is I want to go over our symbols and just kind of label each one. So this one is the less than, and I know that because it looks kind of like an L. This one is a greater than, less than or equal to, and greater than or equal to. Now, the next part, which talks about how to shade it, because inequalities, the solution to an inequality is an entire section of the graph. So you have to shade to signify what section of the graph is the solution set. And this shading is kind of like the trick of the shading that only works in specific situations. So I just want you to be careful when you do this shading that it only works in slope-intercept form. So I'm just going to kind of write off to the side, only works in y equals mx plus b. I don't typically like to show you things that only work in specific situations. However, this makes shading very fast, and oftentimes your equations are in slope-intercept form, so it's helpful. If your inequality is in slope-intercept form, then you can simply shade above or below based on whether it's less than or greater than. So if it is a less than symbol, you would shade below the line. If it's a greater than symbol, you would shade above the line. And that'll make shading really fast. If it's not in slope-intercept form, like when it's in standard form, I'll tell you how to shade over here. And then for the inequality symbols, if they do not have the line underneath, they are dashed. If they do have the line underneath, they are solid. So now let's briefly go over how to graph inequalities in each of these forms. It's very similar to graphing equations. The process is pretty similar, but you're going to have to shade and then do your solid versus your dashed line. So to graph in slope-intercept form, you graph y equals mx plus b, like normal, and then just decide if it's going to be a solid or a dashed line before you actually connect your dots. And then the shading part is the trick. You can use the trick for this one, so you just simply shade above or below. And above are the greater than symbols, and below are the less than. So then in standard form, it's a little different because to graph in standard form, you have two choices of how you graph. So you are going to graph the equation by converting or plugging in zeros for x and for y. If you convert it, then you can obviously follow these steps at that point because you have then converted it to slope-intercept form. But you do have to remember that if you convert, you have to remember to flip your inequality if you multiply or divide by a negative. So I'm actually going to write that right here. Flip sign if multiply or divide by a negative. If you forget to do that, you will shade the opposite side. And then to shade this one, it sounds a little confusing, but once we do an example, it'll make a lot of sense. You are going to pick any point. It's usually the point 0, 0. To plug in, and then you shade where true. If you need more time to write that down, you can go ahead and pause it so I can go through a couple examples when you return. So we're going to graph these two inequalities. This first one is in slope-intercept form. These ones are a little bit easier for us because I can simply begin with B and move with M. So my B is 5. My M is negative 3/4, so I'm going to go down 3 and over to the right 4. Down 3 and over to the right 4. And then before I connect my dots, I need to ask myself if this is a solid or a dashed line. Since this does not have the line underneath the symbol, it is going to be a dashed line. So I'm going to connect this in a dashed line. And then because this is in y equals mx plus b, this is in slope-intercept form, I can simply shade above or below. This symbol is a less than, so that would mean I would shade below the line. So I'm going to shade this side. Now our standard form, we have to do a little bit more work. So just to be able to graph it, I need to either convert it to slope-intercept or I need to plug in zeros. I personally think plugging in zeros is easier, so I'm going to do that. There's also a typo on this one. This is supposed to be a greater than or equal to. So I'm going to plug in 0 for x. The 0 part cancels, we divide, and I get 2.6 repeating, which goes on my y-axis. Then I repeat the process, but I plug in 0 for y. That part cancels, I divide by -1, and I get x is -8. Now notice because I divided by a negative, I flip my inequality. It doesn't particularly matter when you're doing this process because I'm just putting a dot at -8. However, it's good practice to remember to flip when you divide by a negative. So now that I have my two dots, I can go ahead and connect them. I just need to check to see if it's solid or dashed. And because it has the line underneath, it's a solid line. And now here's where shading is a little bit more complicated. Because this is not in slope-intercept form, I cannot just shade above or below based on this symbol. Sometimes you'll be right and sometimes you won't, which is not a good situation to be in when we're taking tests on this. So you have to have a better way that works every time. So that better way is to pick a point to plug in. You can pick any point that's not on the line. I typically pick 0, 0 if I can. So here's 0, 0. So I'm going to plug in 0, 0 to my inequality. So I get -0 plus 3 times 0 is greater than or equal to 8. The reason that I like to pick 0, 0 is because this side will always just end up being 0 because anything multiplied by 0 is 0. So I end up with the statement 0 is greater than or equal to 8. And I need to ask myself, is this true? Is 0 greater than or equal to 8? Hopefully you said no, because it is not. And so that means this point, 0, 0, is not true, which means this whole side is not true. So I want to leave it blank because this is not true. That also means that this whole side is true. So I'm going to shade that side. So wherever it's true is where you shade. If you wanted to double check your work, you could pick a point that is somewhere in the shaded area, like 0, 10. If you plug that in, you will see that that is true, and this whole side should be shaded. Now, this very last thing, I know this video is a little bit long, but this very last point If I ask you if something's a solution, so I say, is this point a solution or not? You have two choices. You can either graph it. The shaded area is the solution. So if the point is shaded, it's a solution. Or you can plug it in for x and y, and any true statements are solutions. So like I plugged in 0, 0 for this inequality, and that was not true, so it's not a solution. If you plug in 0, 10, it is true, so it is a solution. So those are your two choices.